So today I'm going to be working on the state system for Tuxamon, and the state system is basically the system that manages different scenes in the game. So, like one scene, for example, is the combat system. Another scene or state is the world when your character's walking around. It could be like a splash, when the game first starts. So that's what I'm going to be working on right now. Basically, there's going to be a little bit of refactoring, and the creator of the PyTMX map loading library, Bitcraft, actually did most of these changes, and so there's still some problems with it. So that's basically what we're going to be working on now. So let's just take a look. All right. Close these guys. Okay, so let's see where it's at right now. What kind of problems we've got. So now, when you can walk around, get monsters. So right now, this is the world state that we're in. So this is like walking around, looking at stuff. So you can turn up the volume a little bit. Yeah, there we go. A little bit of music. And so again, this is all one state. So if we go and try and get into combat, that will go into the combat state. It's going to switch over to the combat state. So there we go. Okay, so one of the problems is there's no transition from the world state to the combat state. So that's a good starting point. So now what we can do is we can basically create like an intermediary state between the world and going into combat. So there'll be like some flash animation, and then it'll just switch over into the combat state, and then play some music, stuff like that. So let's look at that. Let's see. Okay, so all of our states are under core states. Okay, so and you can see we got start, world, combat, multiplayer. So we're going to need to create a new state so we can switch. This is going to be like a transition state. So let's just create a new module. It's going to call it transition. All right. And let's copy the start. It's kind of similar because the start trend. It's sort of a transition already, so we'll use that just as a something to work off of. Okay, so let's pull this guy up. All right. So instead of start, we're going to call this guy transition. Okay, I'll just change this here. Transition. There we go. So there's quite a bit of stuff we actually don't need in here. So, see where we need to start. So let's look at how we're switching and how we have it. Let's look at world actually. So I had already implemented this in a way, but it wasn't very elegant. And that was in the world state. So here's the world state. Let's see if there's like a transition. Yeah, transition alpha, start transition. So basically world was in charge of like this transition state where it flashes the screen and then starts playing the music. So we want to move that out into transition state. All right. Let's look at, okay, map drawing, high map drawing, interactable. Okay, so let's see. Okay, yeah, so this is where the transition flashing was written in the world state. So basically going to just move all that out. So, okay, full screen animation. So we're going to take this guy out. And let's basically put him in our new state that we're doing. So copy that, come to our transition state. And this is basically going to be in the draw step. So just put that in there. And let's just take out all the splash stuff. We don't need any of the splash stuff right now. All right. Yeah, and we're just gonna take all this out. Not needed right now. Just do pass, so that basically means that that function will do nothing. All right. So to walk through this, so now what we got to do is we basically need to take like a screen capture of the screen, and then we just need to fade that to white, and then back to full opacity, and then keep fading back and forth several times. So when we switch to that, when we switch to transition state, we basically need to give the transition state that screenshot essentially of the screen. So let's take a look at where we do that. So here's some stuff. Let's look for that transition again. Okay, start battle transition. So if battle transition, we're gonna do this. Right, so we need all of this. We hit our max number of flashes. Yep, actually all of this. So that's something we're gonna need. And let's see how we do it. Okay, yeah. So basically, we create a surface that is the actual resolution of the screen, and then we fill it with white. So this is like our just white that we fade into. And then we have the time in seconds between flashes. All right. So yeah, let's put that into the transition state. So because we're moving that out of the world state. So that's like the overworld where your character's walking around and everything. So that's going to be under the draw step. Alright. And I think there's some duplication here, yeah. This is the same thing. Okay, so there's a couple things that happen here. So when we switch to this state, it calls this startup function. Okay, so this is where we'll go to set things up. And then also this params is stuff that we can pass to the state. So I'm going to want to pass that screenshot of everything to the state so it can save it, keep it around, and then we can change the opacity of everything. Then the update method, this is called every frame of the game. So every, if it's 60 frames per second, it's going to call this 60 times. And then this also has the draw call. So this calls this guy, which draws everything on the screen. So, so first step, we need to get that screenshot basically of the world. So let's look at where we can do that. Let's look for this transition part again. All right. So we're creating a surface. We got up, we got down. So basically we have like a count, so like flash this number of times and then start battle. Okay, so this is, we gotta do this screen.copy. Some of these comments are pretty funny. And that's also in here. So we got self.screen. Okay. So up here we need to get that screen. All right. So let's just test. Let's do a basic test first. Let's just try and switch to this guy. All right, before we do anything. So let's just come here and we're gonna comment all this out. I first, before we kind of get more advanced, I just want to see if we can switch to the state successfully. So I'm gonna stop you and print drawing. Okay. And we'll just pass here as well. All right. So right now this is just the most basic state that we can have, right? So it's just gonna do nothing here, the startup, and then it's gonna print drawing every frame. So this is the first step. We just need to get to this state from the world state. Right. So how do we do that? We do, pop state. So that basically removes the latest state from the stack. So let's see. So here's where we start a battle, right? Okay. Like random encounter. Alright. So let's see how we start that. Okay. So we do push state, combat params, the players, combat type monster. Okay. So this is basically switching states here, right? So this is switching to the combat state. But instead of that, we want to just switch to the transition state. So let's just change this to game.pushState, and instead of combat, this will be transition. Right. Params, and right now this is going to be none, but we'll just push these same ones, right? We're gonna take these guys, put them there. And then we're going to comment this out, so because we don't want to go directly into the combat state. We want to go into some transition period that, Flash has placed some music. And then we're setting the current state to true. We're loading the music file, so that's fine. Right, okay. Perfect. So let's see if we can get into that state now. Alright, let's play our game. So this should only happen with random encounters. Okay, perfect. See, so it's calling this drawing, right? It's just printing it over and over again because that's every frame. And it's just frozen here because we're not updating the screen at all. So that's what happens there. So, but it plays the music, so that's good because that happens in the event here when there's an event that starts combat. Cool. So now with this push state, we need to push that screen and then the copy of it so that we can, animate it flashing. So, let's see. Everyone has game. Alright, let's just take a look. Let's do... We'll send the player's combat type. Then we're going to do screen. Okay. And then we'll do game.screen. Okay, so this is basically just a copy of the screen. That game.screen object. And then now in our state, so in this state here, so now params is going to have that screen. Just like that, right? So this dictionary that we're passing when we do push state, we're going to get a copy of that screen, right? And then we need to basically create a copy of it, so that's pretty simple with this. Let's see what we call it. Now we do self.screen.copy. So let's just call this transition surface equals, and then it's going to be self.screen.copy. All right. Okay. Now, do we have a copy of game? Don't think so, which is very odd. Let me look at the world state. Let me see how it's getting game. Self.game. Oh, I see. So there's a prototype state. This guy, no, not that one. State. Here we go. Okay, yeah. So yeah, they all have a copy of the game. All right. So let's go back to our transition state here. So we do have the game, this game variable. So the game variable is like it has a control object that manages all the states. So, and it also has a copy of the screen, which is what we draw to in the game. So, let's see. So we uncommented. So we're going to be filling the screen with basically like a almost black color. And then we need to create that surface. So let's just try self.game.screen screen.blit, and then we give it the surface we want to blit. So in that case, we're going to self.transition surface, and then where we want to blit it, we'll blit it to the top left corner of the screen. All right. So let's see, why is that? Oh, yeah, that A. There we go. So let's try this again. Move this over. I need to like increase the counter rate of this. Okay. Alright, so this is working right. I just need to figure out a way to make sure it's working. Okay. Let's try this once. So let's, instead of doing that, we're going to blit it with blackness. I just want to make sure that we're drawing to the screen correctly. And then we can start changing like the alpha coloring of everything. Yep, cool. So it did switch to here and it's drawing black, like almost black. So in here, so let's start taking our original code that we wrote for this transition. So we can start this battle transition totally right there. Oh yeah, you've even got like some rumble support. So it'll rumble when it first starts. Okay. Okay, I see. I see. So the transition surface is going to be just whiteness, right? So actually, we'll just call this. You know what? We don't even need it actually. We'll just do a screen.copy right off the bat. So in this case, let's just redo this. Okay, start battle transition. Let's add that. Start battle transition equals false, right? So the first time this draw gets called, actually, so this should be true, right? And this, we should actually be doing all this in update. So let's do that. All right. Okay, so if we're at just at the start of this battle transition, then we log a message. We say initializing battle transition. We start a rumble. So if you're using a controller, then your controller will rumble. And then we set battle transition in progress to true. So let's create that variable. Battle transition in progress is false at the beginning. So when you first switch to the state, this is going to be set to false. Then we create a transition surface. So we can actually do that up here. Let's just start this off right up here. Right. So we'll create a new transition surface. So this is basically going to be just a white screen. So we're going to fade into that and then fade out and fade in, fade out, fade in. All right, so then we set battle transition in progress to true. And then we set start battle transition to false, right? So this will never get called again until we reload the state. And then we also block player map movement, but actually this is going to happen already since we're moving to the state. All right, so okay, so now here we're blitting our transition surface to the screen. So we don't need this anymore. We don't need to draw black. And we don't need that debug statement. Oh, hey Tamashi. How's it going? All right, let's see. Alright, I was caught off. Well, a little off track. Okay. So if our battle transition is in progress, we log that. We set our flash time. So we'll bring this up here because we don't really need it down there. Not there. Flash time. Okay. So, and actually, yeah. Yeah, we're gonna need this time past seconds. Okay. So here's the battle flash state. So that's basically just a way we can tell, are we, going up into a bright flash, or are we on the down part of the flash? Hey, Susaji, how's it going? Yeah, so this battle flash state, we'll just set that to none when it first starts. We might actually need to change that. But so right now what we're doing is we're trying to get this battle transition going. Oh, and then it's broken. Line 180. Oh. Okay. So yeah, so right now in Tuxamon, I'm trying to get this new state system working. Basically, the state system is, switching between combat and like the world when you're walking around. Yep, Python, dude. Python's the best. It's my favorite too. So yeah, if I get into a battle here right now with this new state system, hopefully, oh, it failed. But basically, there's no like flashing or transition state between walking around on the world and then getting into a battle. So let's just kill this guy. All right. There's no self-dot resolution. That's fine. How many classes do I need? I'm not sure what you mean by that. Like, game classes? Classes for the whole game? Or classes just for this? I'm not sure. Okay, so we needed, instead of self.resolution, we need prepare.screen size. Yeah, it kind of depends. Java is like a statically typed language, whereas Python is dynamically typed. So, if you're programming in something like Java, you have to, if you create a variable, that variable has to be an integer or, a string, and it can never change. So, and in Python, you can use that variable, and it can be a dictionary, it can be a string or an integer. So it's a little more flexible, but sometimes you might not know, like, what are these variables? What is this? Is this going to be true or false, or is it going to be an integer? So if it's not written very well, then it can be kind of hard to tell what is going on. So, but I like it. It's actually pretty easy to use, and I like it. It's nice. Okay, so we're creating a surface. So in Pygame, these surfaces are basically like, these are things we draw to the screen. So these are like they could be an image that you load, like a little PNG graphic that you load, or it can be just an empty surface that's just like transparency, that's a certain size, or you can fill it with like a color. So like in this case, what I'm doing is I'm creating a surface that's the size of the screen. Actually, this is not screen rect, it should be screen size, right? Screen size. There we go. Oh man. Screen size. There we go. Yeah, they dynamic variables can be nice. And you can what's nice in Python too is like you can kind of test like, okay, if this is false, then something failed. If this is like a dictionary, then I know that that operation was successful. So, do that a lot. And you can also do stuff like, it's sort of like duck typing. You can give it different things. Like I can give it, I can give it a player object. And so, you could have these two things. You could have like a player object and an NPC object, and they can be different. They can have different method, like different. They do different things, but as long as they have the same methods, like NPC has walk and player has walk, you can just call those, and it doesn't. There's no checking what object it is. It's just if it has those methods available, stuff like that. So it's nice. All right, so okay, let's try and get this somewhat started. So we've got when we first switch in here, when we first switch to this state, we're going to have this start battle transition. So that's going to give us an opportunity to set some stuff up, like start rumbling the gamepad and saying that we have this transition in progress and setting up some stuff. Then we're going to create our surface. So this is going to be the white screen that we're going to flash into. And then we also define some stuff like how long between flashes, right? So time in seconds between flashes. And then this battle flash state is going to be used for just tracking if we're already at the apex of a flash, right? So it's like it's flashed all the way white, or if it's at full opacity for the image, right? So it goes back to you standing there in the grass. So that would be like the down state, and then the up state would be like a full flash, right? So actually we'll start this in the down state, right? So that means that we're displaying our little character on the overworld, and we're going to try to flash up into there so that once it goes up and down X number of times, then we'll just switch into combat. All right. So yeah, you can see here. So like, if the battle flash state is up, then we're going to get this alpha value. So this is like how transparent it is, and we're going to keep increasing it, right? And then we do it by the amount of time that's passed and how fast we want to flash. And then if it's down, then we lower the alpha. So actually, I messed up here. So we should actually we should start in the up state, right? So that means we are flashing up into that whiteness. Okay. So, and this all can be in the update part, right? Because we're not actually doing any drawing here. So we should do this up higher. So if battle state transition in progress, this alpha state stuff, if we hit our maximum number, Right? Okay. Alright, we're slightly offset here for some reason. One thing about Python is indentation. It's very strict about indentation. I just prefer this editor. This is Vim. And I'm still not an expert at it, but basically you can be really efficient in Vim because there's like all kinds of commands that you can use to like copy and manipulate text real easily. So I just like it, and you know, trying to get better at it. So okay, so yeah, this is only 3. Okay. There we go. Better. Okay, this indentation is off too. Okay. Start battle transition should be up here. Yeah, I used to use Eclipse with the PyDev add-on, and yeah, it's nice. You know, pretty much whatever you prefer is, you know, what you should use. Some people just use Notepad, you know. Okay, this undefined name flash time. Okay, that's all right. So right now, if our battle transition is in progress, and our battle flash state is up, we're gonna set our transition alpha up to a higher amount. Okay, so let's yank to here. Actually, let's take. Okay, so let's take this guy. So we're gonna need this guy as well. Oh, not flash state. Sorry. What was it? The alpha. This is what we need. So right now the alpha is going to be 0, right? So there's 0 transparency. Alright, so in this case it's going to increase the alpha. So instead of this time past seconds, so that was the sort of the older, not as great way, we're going to be using this time delta. So let's delete here, and then this is self.flash time. This is also self.flash time. Okay, so let's just kind of go through this. So if we're in the start battle transition, right, so when it first starts up, we're gonna rumble. So, you know, actually we could probably get rid of this and just bring this up into the startup part, right? So because this startup is only gonna run once. Put that right there. And transition in progress. I don't think we even need that. So start transition. Okay. So yeah, so we don't need this. I don't think we need either of those, actually. Because this is all going to happen in the very beginning. All this stuff. Alright, so start battle transition. Don't need it. Don't need that. It's kind of the old way. Don't need this start battle transition in progress. Yeah, no, we don't need that. We just need to know if it's flashing up or down. Alright, so let's just take this. Take it back. Okay. So, again, so we're flashing up. So if we're flashing up, we're going to increase our battle transition alpha by 255 times the amount of time that's passed divided by the time we want in seconds. Oh yeah, I know. If there's no comments, it can be really hard. Yeah, I try to document everything in Tuxamon the best I can, and then like these streams just kind of makes it more transparent as to like how the development happens and like what my thought process is for why I do something a certain way. So yeah, I think it's a good part. I don't know how the delay is low, Tamashi. It's because I'm on Linux, that's why. Alright. So now we also need this count, right? So let's yank this. Alright, so now we have this flash count. So we're going to need the total count. I think we have that somewhere. Let's see. Yeah, max battle flash count, right? So there's two things that work here, right? No. Equals, so say we want it, so right now we're setting this to 7, which I'll explain in a second. So I do some programming, but it's mostly like managing servers, stuff like that. So this is more of my hobby on the side. So this is how this is going to work. So we have these two things. We have the flash count. So this is basically how many times we want to flash the screen, right? And then this is our current flash count, right? So this is just how we keep track of how many flashes we've done. And then as soon as, this battle flash count, equals this flash count, this battle maximum flash, then that's when we know to start combat, right? So we switch, so we're in the world state, we switch to this state, and then that's where we, flash 7 times, and we keep track of those. And then as soon as that's done, we're going to swap into the combat state. So that's going to actually start a battle with, whatever monster. Or a creature, sorry. Okay. So we've got our max flash count. So here, So if our battle flash state is up, we're going to increase our transparency. Yeah, so it's going to flash 7 times, and then this is what I set the time for. So each flash, going up, is going to be 0.2 seconds. So that it's going to be really quick. It's the whole transition's maybe like a couple second or two. So so then and then now, so here what we're doing is we're flashing up, right? So that means we're going into the whiteness, and then we keep adding to that based on how much time has passed, and then how long we want each flash to take, right? And then if we're going down, right, so it's full white and we're coming back down to the full, your little character, and we're going to decrease that. And then here, so if that transparency, oh nice, that's nice to meet you. All right, so yeah, so if this transparency is greater than 255, so that's like the maximum, that's fully transparent, right? Then we're gonna switch it back into down, right? So that means we flashed all the way white, and then we're gonna start heading back down. We're gonna take away that transparency, and then once we reach that up part, we add our flash count. Yes. All right. So we did our battle transition, so we don't need that anymore. If our flash count is greater than our maximum battle count, let's say we flashed, and then okay, then we set our flash count to 0. We actually don't need that because we're going to restart the whole process again. So this game, so now we need to do self.game.push state, and then now we're switching to the combat state, and then params. So this is going to be like what player is in there, like what the player is gonna, like the actual player playing, and then the NPC that you're fighting, or like some monster that you're fighting. So we're gonna give that to the combat state, so we have the ability to actually set everything up, get their monsters and their sprites all prepared and all that stuff. So yeah, so there's there's a couple people doing quite a bit of work. So like right now, what I'm working on is there was a contributor called Bitcraft, and he totally redid the state system, kind of cleaned it up, made it better. And so, but there's still some problems because of the way the old system was. So that's what I'm trying to do right now, is sort of fix those problems to kind of glue his changes into making everything work. And then also, Pastak, he made the online multiplayer. I kind of helped, we sort of collaborated together. He's actually one of my close friends. So yeah, he worked on that, and I try to make sure everything's commented. If someone contributes something and it's not commented, then I'll go in and like make sure everything's commented and kind of clean. Okay, so let me see what we need. So this combat event, let's take a look. Okay, so yeah, so now we're pushing this to transition, and we're giving the transition state our player 1 and our NPC and what combat type it is. So in this case, it's monster. It could be like a boss battle or something, and so we might want to change how combat works. And then also the screen so that we can draw to that. But we actually don't need that, but not a big deal. So let's just take this, because we're going to do a similar thing. And that's going to be under our states transition. Okay, so it's right here. Oops, there we go. So push state. So instead of transition, because this is inside the transition state, we're going to combat, right? So, and let's bring up, so because when we start combat, when we call this transition state, these params are going to also have this stuff that was pushed to it, so which is this guy. So let's set that up. What? Come here. All right. Okay, so let's do self.combat params equals params. So that's actually all we need. Let's kind of separate that a little bit. Okay. So right now what's happening is here's our combat event. So basically this the map editor is set up so that you can call one of these things. You can just say, you know, start battle with this trainer, or, you know, start a random encounter here. And so we're passing, we're basically going to be switching to the transition state, and then we're going to be giving it the players, the NPC, and like what kind of combat type it is. And then in turn, in the transition, which is in here, so we're getting all this data under params, and that's all coming in right here, params. So that's gonna, I'm setting that to a variable called combat params. So then when I come here and do push state, we can just send those params. So we'll just do params equals self.combat params. Right? So we're just going to be sending all those things over. So we're actually almost done. So we got everything, like we're keeping track of the flashes and everything, and then now we just need to actually draw those flashes. Yeah, we can have different transitions, and that's what's good about you know, now I'm kind of separating those transitions into like its own file, its own state, so we can change it, you know, maybe based on what type of battle this is, right? So right now, like, we're sending under params, it's params, you know, combat type, and if that is, you know, monster, then we want to do, you know, this kind of transition, or if it's boss, then do this kind of transition. So that's totally possible and pretty simple to add. Right now we're just gonna have one transition, but yeah, if we want to do some different ones for like different bosses, or maybe certain players or certain battles, we can have like these different transitions that might do something cool. So all right, so we are pushing our state, and so now we just need to handle drawing. Okay, so we're going to draw that screen. So, okay, yeah, so I see. What we're doing here is this transition surface is just whiteness, right? And so up here in the update part, we're just changing the whiteness of that, or the transparency of that white. So what we can do is, let's make let's do screen, yeah, self.original surface will be screen.copy. So, what's wrong? Undefined name screen. Oh. Self.screen. Okay. So this copy of the screen is basically like you're going to be your character on the map right as the battle happens. And then this transition surface is just going to be white. So we're going to be, and then we're going to draw that whiteness over the original surface. And then originally the transition surface is going to be fully transparent, and then we're going to up the transparency so it goes into whiteness, and then back down. So we do that 7 times, switch to combat, and then we're done. So all we need to do is down here, we just need to draw our other one, self.game.screen.lit. So this is our original surface. This is the top left pixel on the screen. Right? And then here, this is where we did that already. Okay, yeah, here we go. So here's where we set the alpha of that transition surface, right? So let's take that. And we actually don't need that. Alright. So let's just say, flip the original surface to the screen, and then set the alpha level of the screen and fill the screen with white at that alpha level. Right? So this is our in the very beginning, like the alpha is going to be fully transparent, and then as we go on, it keeps adding it keeps adding that alpha layer. So I think that's it. We can get rid of all this stuff, so this stuff's not really needed anymore. I haven't done really any mobile stuff with Python. It's kind of hard. But there is ways to run Python on like Android. And actually Tuxamon works on Android. I think I might have a version here I can show you real quick. There's a couple problems, but let's see. Where are you, Tuxamon? There you are. Yeah. So right here, walk around. So it does work, but it's a little bit of a pain. All right. So back to this. I don't think we need that. Transition alpha. Yeah, no, we don't need that. We don't need this shit. Alright. Well, let's see how this works. I'm not sure how well it will, but let's try it. Get our monster. it flashed, right? Let's look at that again real quick. Yeah, so this worked, right? So it... Come on, monster. Yeah. Okay, so the flashing works, so it goes to the transition state, does that. So combat object has no attribute, start battle transition. Yeah, I know. I'm happy it flashed too. It's funny, like, you'll be working on something for a long time, and you get it working, and it seems so small, such a small thing to get working, and you're like, hey guys, come look at this, and it's like, yeah, it's flashing. Congratulations. No, you don't understand. Alright. So this is something with the music. So this music is assuming that the world state is going on. So that's event conditions music. Event conditions Musak. Alright. If world this doesn't even make sense. I don't even know why this is here. Take that out. Let's try this again. I'm glad you know what I mean. Come on. Come on. There we go. Dude, look at that. Beautiful. It worked. So I'm not sure what's gonna happen if I run away. Oh yeah, it worked. Perfect. Done. Alright, cool. So that's good to go now. Don't stop testing. I'll keep. You want to keep testing? No, there's still a lot of stuff. What happens if you run from a fight and then fight again? Oh, let's try that. Yeah, you're right. You know, that's good. We need to do those sorts of things. Yeah, and there's still some other problems too with you know, trying to get this new state system working. So I'm trying to get it working, and then we can accept those changes in the new, you know, development version. So that should make it. It's pretty nice. It also the way Bitcraft made the whole like switching states. It also made it lighter on memory, so that, you know, when you go to combat, then it clears stuff out of memory and stuff like that. Yeah. Okay. Dude, this rock kitten can't handle it. Get wrecked. All right. Well, there you go. it crashed. All right. So, what happened? Key error player. So, for some reason, the player doesn't exist in there. Alright, so this is in the combat state. Let's take a look at that. States, combat. And this was under line 611. Okay, so try to loop through this player's monsters, but player didn't exist in there for some reason. So let's see, where is this? Is this in, okay, this is in the draw step. So for some reason it got removed. Now this is more just hunting around, like why is this happening? So let's see pop state. Okay, event actions. So we fade out the music, and then we pop the state. So basically we go back to the previous state. So we were in let's game dot states state stack. Too many prints. Okay. Let's go. So there could be a couple of problems. Well, that's one of them. Okay. So if we run, that worked. And our stack is basically, is in the combat state, and we had the world state, and then the pop basically just removes this state from our stack. So it basically switches back to world. Whatever's the, this first item in the list is going to be the current state. So now if I win, oh, no, that's not gonna work. Okay. Take that out. So we run away. Pop the state. Yeah, so let's go back to our transition. So when we switch, oh yeah, no, we do that, okay. Yeah, so pop state basically means remove the transition and then, start combat. So, yeah, thank you, Toger. Let's let's see what that error was before. So player is missing. Oh, it's a little light. Okay. So there seems to be a problem. Use enum or some dick to define often used words. An enum or dick? Like, I'm not sure what you mean. Is that like translation type stuff? So you can like fight like these menu items? Yeah, so this bug only happens when you defeat the monster. So as soon as you defeat the monster, the player gets removed for some reason. So that's something we gotta figure out. And there are some things like so in prepare, this one right here, prepare. We do have like some stuff defined. There's not really like words. I mean, we might add some, you know, and it'd be cool to have maybe like some translation files and stuff like that. But yeah, so like things like tile size. So these are constants, and so you can access these at any time, like anywhere in the game. You can access all these constants. Like the player, or the tile size, all that stuff. Yeah. Player up, down. Yeah, not really. Those are not really defined anywhere. But they probably should be. Especially like if we want to start doing, you know, translations to any other language. Because right now it's kind of hard-coded in English, most of the stuff. So yeah, it would be nice to maybe have like a file where you can just, you know, have a variable for those strings, and then, you know, you could just, depending on the language, like you could choose any one, and it would all reflect correctly and everything in the game. So probably need to do something like that. All right. No, it's not a bad idea at all. It's actually a good idea. Okay. So this is happening in combat. So let's see if there's like a delete. Actually, it's going to be in self.players. Yeah, params players. Okay, when we call shutdown, we set everything players. Okay, let's try this. Shutting down now. Oops. Okay, so right now I'm just trying to figure out why the players, that key is basically getting taken out. And that's causing the game to freeze, basically. It crashes. A certain part of it crashes. Okay, so let's kill this big fin. the music is also there's another problem with that. It's not playing like the actual battle music. It's still playing the background map music. Okay. Yeah, that's awesome. Actually, I didn't know that they're all in Skyrim. Um, yeah, I mean, like in Tuxamon, actually, like a lot of stuff is just plain text. Since it's an open source game, I figured there's no real reason to kind of mask anything. So a lot of stuff is just text files. You could just go in with Notepad and play around with stuff. So I kind of like it just plain text. Um, and there's not really like a normal way necessarily. There's like a lot of good patterns that people use to do translation in like games and stuff like that. And there's some that are pretty good that I'll probably end up implementing later. So there's like a couple that are like the best way usually. And yeah, the key error, because I didn't actually fix it, but I did put this text in there to see if it was hitting that part of the code. So, and it is, so I know that it's probably related to this shutdown function, right? So, see, I put in here print shutting down now, and I think this is what's doing it. It's basically like killing the data maybe prematurely. So, and let me I want to run it again just to see if it does that if I run away, because it doesn't crash when I run away for some reason. Yeah, I know it's definitely weird for like big, AAA company to just have like that stuff so easy to access. Oh, that's weird. Man, so it also hit it here when I ran away. So there's something still changing it that's a little bit different. So, okay, it's this player dictionary. Yeah, it's this guy. So what is player? Okay, for player name, player in current players. So for some reason this is empty. Yeah, I do. I don't really use like the Python debugger though much. I don't know. I guess I'm kind of used to just like putting in print statements and then figuring out what happened. When exactly does the memory cleaned? Not sure what you mean. Oh yeah. Yeah, let's see. So if it's run away, I do this. Which all looks good. And now if combat ends, that's another part. Let's see. Okay, it's probably in U1. There we go. So, if the state is 1, okay. So here, we fade out the music. Yeah, that would be probably a good idea to have an end combat function. That's a good idea. Yeah, I know. Since this is sort of involved. Yeah, I know. I did. Yeah, since the code has evolved, like it's sort of there's sort of some redundancies right now that could be refined. So consolidating like ending combat would be a great way to do that. In fact, let's do that right now. Let's at least these two things. So that may fix our problem, and then it's also going to remove some redundancy from the code. So right now, pop state. So this is basically ending combat. So let's do that. Let's take these lines of code, and we're going to create a new method. It's a lot of stuff. So end combat. All right. So, and then we're gonna need the game. Let's see where we get this game object. Oh, okay, it's just self.game. Okay, so we don't even need that. So end combat. So we don't need any parameters. We can just call end game. And oops, delete this. Oops, delete that. And so instead of game, it's going to be just self.game. So that's the copy of the state manager, which manages all the whole game basically. So when the game ends, basically just going to fade out the music and pop it from the state. So, and we're gonna want to change it right now. I just want to like all combat. The way it ends is it just takes you back to the world map. So I'm gonna just add something here to say like to do end combat differently depending on winning or losing, right? So because we don't want to just always do the same thing at some point in the future when you win or lose combat. So for now, that's what's gonna happen. So now let's look at our pop state. Let's look for that part. So now instead of doing all this shit, we're gonna do self.end combat. Boom. Now we can delete all this stuff. And then we did teleport, but we don't need that anymore. Okay, so now let's look for the U1. So if it won, then instead of doing all this crap, jeez, this function is like gigantic. This, not function, condition. So then we're going to call self.end combat, right? Alright, let's see if there's any more pop states. I don't think so. Yeah, that's it. Cool, so that should be everything. Let's see how it reacts now. Might still have the same problem. Move this. Yeah, still that music problem, which I'll have to look at. Dang, one shot. Nope, it still failed. I guess the difference is when you kill a monster, it might remove that monster. So instead of running away, when you run, it may not actually like remove the monster from combat or anything like that. But let's just print out what player even is right now. So it's at 611. So let's just print player. I know, dude. He retaliates with crash your game. We should make that a technique. Crash your game technique. Oh, Jesus. Look at all this. Okay, it's just constantly printing. Alright, it's alright. We'll find out what happens. This one's tougher than the other rock kittens. Okay, let's see what happens. Alright. So it basically changed that player into just health changed false. Yeah, I think there was something that would just delete your save. I don't remember the details, but that would suck. Especially if you spent like thousands of hours. Could make the whole game Tuxamon, since it evolves and runs and occasionally dies. Yeah. Alright. So for some reason this player is, it just has this health changed, right? But it should have this part, the actual player object. Yeah, we could have like a hard mode. Your Pokemon, your party gets wiped out, then it deletes your save automatically. We should do that. We should do like Iron mode. So this is in current players. Animate health. Current player. Okay. All right. So for some reason, we're getting our dictionary is being modified. So our startup has it just creating an empty dictionary. Oh, okay. Huh. All right. So because it creates health changed right off the bat, and that is what is here. So I think startup is being called for some reason when we go back. Let's just add another little, right? Print starting. All right. And actually, we should change the other one. Yeah, we don't need to print player anymore. So. Doo-doo. All right. So the combat state started up once. Okay. Now when I run, doesn't start up again. That's good. Right? Doesn't start up. But now it started up. And now let's kill this guy. Let's see if it starts up again. Because that's what I think is happening. Is it's hitting startup twice for some reason. Nope. It's not. Huh. That is peculiar. So, when I killed the monster, it didn't actually call startup, because otherwise we would have seen, you know, starting up. We would have seen that print statement. How peculiar. So it's not this. That's freaking weird. Cause where else could it be? Alright. Current. Okay, shut down. No, we did. Yeah, we did. Oh, okay. But shutdown happens both times. I don't understand. Okay, let's look at what else is happening when we run. So if we select run, we end combat. Done. We win. Okay, and this is in which state? This is probably in, okay, get event. Yeah. Yeah, actually, with this new state system, we are actually gonna start implementing some unit tests. So hopefully this type of stuff will be easier to test and figure out. But this is what we got right now. Okay. So when we run, that happens at the get event part. And when we win, we set state to 1, and then if capturing, okay. If the state is lost or won or captured, then we end combat. You know, I bet it's something, Okay, once them all appropriate amount of time. I'm wondering if it's related to just the order at which they're being called, because this is in like the update part, turn update. Whereas when you run away from combat, that's in the get event, which is, yeah, this get event. This basically handles player input, right? So when you press enter or something, it calls this method and handles it. So like when you select an item from a menu. So it could be just the order in which that happens, right? So get event might be called first. Yeah, Python's pretty easy to get started with. Okay. Alright, we might need to look at how shutdown is being called, like in what order it's being called. So let's look at our state. So get event, update, startup, resume, pause, shutdown. Okay. So our state manager. So this is what manages the different states. Okay. Push state. Current state. All right. Okay. So when we pop state, we call shutdown. I think this has got to be it. Yeah, there's there's a lot of different ways you could do that, solve that problem. Yeah, I think one good pattern is using like managers and then just passing objects. So instead of having methods inside your classes, like having those buy sell methods, you'd have a manager that would do buy sell, and then you would give that manager your player objects and your market objects, right? So, and then so all those classes that you'd make, like your players, your market, all that stuff, they just have properties, right? So they don't really have any methods. They just have properties, and then the manager actually manipulates those properties of those objects. So it'll do stuff like for buying and selling and stuff like that. That's not the way I started Tuxamon. I sort of think it might have worked well for it, but yeah. So like right now, the player, it has all of its own. It has its own methods for everything. It has a method for walking around and adding monsters to its party, adding items, stuff like that. So it kind of makes it very heavyweight, and so it can kind of cause some problems. So I kind of like having them just being simple objects, not having their own methods. So I kind of wish I could have gone back and done it that way instead. But it still works. It's still, both perfectly valid ways of doing it. So, all right. So this is where I think the problem is happening. So when we call pop state, so we're done with the combat state, right? We're calling this shutdown method on that state. And I think that is where it's breaking everything. So, and actually we don't even really need this, like we don't need to do much in shutdown. Because with combat is not going to persist, right? So as soon as combat ends, I don't need any of that data anymore. I don't need to know, I might need to know like whether the battle was won or not. So like if I'm doing some special events and stuff, it'd be nice to know like if I won a boss battle or, whatever. But everything else I don't need. So it's as soon as combat ends, I can just clear all those variables. I don't need anything from there. And that's sort of what I did. If we look at our combat, so here's our combat state. We have this shutdown method that gets called whenever we do pop state. So I'm gonna just try to do nothing, okay? So, because all of this stuff is actually going to be cleared anyway, because we're basically deleting the state. So it's gonna clear it all anyway. Theoretically. let's see what happens. All right. So let's make sure that I can run away still. That didn't break anything. And then I'll try to actually just like win a battle and see what happens. Man, I need to increase. I'm gonna do that next. I'm gonna increase the encounter rate. I just didn't want them to be like Zubats, where like every step you take, it's a freaking battle. Okay, so let's run away. Okay, cool. So that worked. And cool, we got another battle. So let's take down this rock kitten. Oh, no one shot. Boom! Boom, that was it. The shutdown. So, yeah. Oh, nice. It's working. Beautiful. So, there's still this, the music bug I want to work out, too. Because it's actually not playing the right music. Alright. Alright, one thing done. Sweet. So, yeah, we can just delete this whole thing. We don't even need this. Boom. Beautiful. Yeah, so that shutdown was really more of a remnant of how we were handling the states before. So this is the new state system handles it a little differently, so that was kind of just one of the blockers that we needed to fix before we can get this new state system into the latest development version of Tuxamon. Alright, so the next thing with the music, I actually deleted part of the code that I think was supposed to handle that, which was in this like music playing. So really what we need to do here is we need to check what's happening. Alright, let's look at Tuxamon states. No. Components, event, conditions, music. Oops. Okay. So here, I'm doing things a little differently. So if we're in a battle transition, or there's a battle transition in progress, or we're in combat, return true, meaning music is playing, don't try and play new music. So this is what I think I gotta do with our new state system. But it's a little different. So because with the new state system, like, combat may not even exist, so it could cause it to crash the game. And so that's part of the whole, it's a lightweight state system, so that, if we don't need combat anymore, then it frees it up from memory. So we need to figure out how to get the current state. And that's going to be under state. And there's the state manager. This guy. So we got our state stack and our state dictionary. It might be current. Okay, state name. This is probably. Yeah. To do phase this out? Why are you gonna want to phase that out, bro? Alright. I mean, I guess we could just get the current state and then look at it something like that. Okay. So let's get the state name, and then we need to check to see if it's like a transition state or a combat state. Then in our music playing condition, we need to say, yes, music is playing right now. Yeah. So game dot state name. So let's just print it. So I would like to know what this looks like. State name. And let's just give this a test. Okay, so state name, world. That's perfect. That's exactly what we need. So in this case, we need to say like, if game.state name is transition, or game.state name is combat, then we need to return true for here. So this is a condition that I have set up. It's called music playing. So basically, in the map editor, you can say, you can check to see if music is playing, and then if there's none playing, then you can start playing music, or handle that however you want. So in this case, I want to make it so that if we ever switch to the transition state, or if we're in combat, that to always say music is playing, right? So that whatever music the map is handling, and the world, like the overworld, it's not going to be it's not going to override the combat music. So hopefully that should solve that problem. Let's see, maybe get a little more volume. I don't remember if I got a monster. Yes, I did. Okay, cool. All right. Yeah, beautiful. That fixed that. That was easy. Let's just test this out again. So, yeah, perfect. This is fixed. A lot of the blockers that we needed to fix. Oh, that's also sort of a bug. All right, cool. So now there's still a couple other things I need to test with this new state system. One is like capturing monsters. So I had already implemented a capturing system. So let's see if that still works or not. Okay, let's poison him. So there is actually like you don't have 100% capture success right now. So, but if you poison them, then you'll have a higher chance. So let's try it. And I missed. Alright, let me just poison him some more. Let's see if it works now. It's another thing you gotta fix, the animation. Cool, so it captured, right? Let's see if it ends combat correctly. Nope, it froze. The FPS is just the same. Dang, alright. So yeah, we don't need this anymore. Okay. Let's get a little light. Okay. Stretch. So we need to look at. Actually, I want to test that again real quick. So right now the transition animation is working. That's good. And we can run away successfully. And now I just need to figure out why capturing froze. Alright, you know what? Hold on. I need to change the encounter rate. So I have the encounter rate set up actually in here. DB encounter. So, and here's the encounter rate. So I'm just gonna like up everything to 50. Just a couple, I guess. Okay. That'll make things much faster. There we are. Okay. Hopefully this works. Ah, dang it. Yeah, I do actually have a console for adding items and stuff. It's not super easy to use right now, so it's sort of faster to just do it manually. But I do want to like add some quick commands so you can like add a bunch of capture devices or something and stuff like that. Dang it. Now I have no capture devices left. Okay. Yeah, see, this is the actual console here. So here I can look at like, let's from pprint input. So this is like a full Python console that you have, and you have access to like everything here. Yes, exactly, Toger. So yeah, I can look at like all the game variables in here. So here's like player one dot player one, and here's like the inventory. Where's the inventory? Right here. So it's just empty. But when I come over here, got Fruitera and some items. Now I've got inventory, potion, capture device, quantity 2. So here I can just change that value from this console. So I can do player 1 dot inventory capture device quantity equals 1000. Boom. Now I have 1000 capture devices. So you can see it, so it sort of takes a little while. Like I said, I want to make some shortcuts to that. But yeah, there is some kind of that, you know, debug console functionality in it right now. So I think, okay, he's level 1. Missed. Just keep trying. There we go. Capture. Okay, and we're back. So yeah, it worked. Cool. So that looks good. Yeah. So I think that was like a pretty big part. Can you use your new Tuxamon? Oh, yeah, actually, I think. I'm pretty sure. Sorry, I ended that. But yeah, you can view the monster, or the creature, sorry, using sort of negative. Monster has such a negative connotations with it. Yeah, I can show you how I capture. I think that you can switch out to him. There's not like any animation at this time, so like he'll sort of just pop up, I believe, but I'm not sure. Let me double check. Let me just whittle him down a little bit. Dang. Didn't get him. There's actually the calculations down here, the bottom of the screen, where if it's above this number, then you won't capture him. So that's the capture calculation. Ah, we did it. Yeah. Okay. So yeah, you want to see if we can use our new monster in combat. But it froze. It froze. I don't know if you could tell the frame rate. It's just empty. I'm not sure why it freezes like this sometimes. It's another problem. It might be core. Actually, I think I can fix I might be able to fix that freezing problem right now. It has to do with like the events. It's like a Pygame thing. That's what I'm writing Tuxamon in is uses the Pygame engine. And I think it's like the engine actually freezing up. And I implemented a fix about it before. State.py. Maybe it's okay. Control.py. Okay. So it's in here. Nope. That was what I thought I was. Could have fixed it. The back sprites? I don't know what you mean. It should work. Yeah, you just add it as a monster and just let it know where the back sprite is and it'll work. Yeah, unfortunately, I'm not sure. Oh, really? Is it? It might be the placement of the monster, but let's try it out. Like, tiled. Actually, we can just do resources, maps, tiled bedroom test. There we go. So tiled is the map editor. Wait, what? He's not standing on the... Oh, you're talking about Fruitera is not standing on the left? Oh, I see what you mean. Well, let's see what it looks like. Not sure. So this is the map editor that Tuxamon uses. No, it's okay. I mean, we should change it if, you know, if people are assuming that that's kind of the corner that it's in, then, you know, we might need to change that up. So yeah, so this is the map editor that Tuxamon uses. It's called Tiled. It's like a free open source independent map editor, but Tuxamon uses it for all the events and you know, actually making the maps. So like these events are where you can define stuff like, you know, adding monsters, right? So in here, we'll just change this. So instead of Fruitera, we'll change this to Sumo Bug. All right, for sure. Well, I kind of still just want to check it out and just look at how it looks right now. So let's see. So now instead of Fruitera, we're going to get Sumo Bug. All right. Now let's just close Tiled and come back here. Now we got Sumo Bug. Oh. This failed though. Maybe I messed that up somehow. Oh, you know what? Sumo Bug isn't in this branch. Yeah. So I'd have to manually add him. So, cause yeah, so there's two spots so that you can be facing, you know, you can be at that bottom tile or the top tile. Oops, wait. Wrong directory. So maps. Tiled bedroom test. Yeah, so zoom in. Yeah, these two events here. But see, these are the conditions for that event. And one of the conditions is that you have like 0 party size. So it's only going to work once. You won't be able to go to this and then hit enter, you know, to get a monster, and then come up here and then press enter and then get another monster and items. So it's only going to happen once. And there's other ways to do that, to like set variables and stuff so that it'll work. Right now, you actually could. You can do that, actually. Yes. So, well, no, you would still need 2 events. They can both be on the same tile. But the problem is that the way that the event system is set up is that all of these conditions are all and, like, they're all inclusive, right? There's no like or. There's no or concept of or in this. So the only way to do like an or is to have a separate event. So yeah, right now, like all of these 4 conditions need to be true in order for these actions to be executed. So, I mean, it's certainly possible we might be able to add, like, you know, if is player at here or is player at here, but it sort of makes it a little more complicated to use. So I'm not sure about maybe a more elegant solution to that. But, you know, I'm open to ideas. If someone has like a nice way to do that, it might be worth doing. So I don't know. Okay, so yeah, so sumo bug is not in this branch. Because basically what happened was Bitcraft, he went and he forked Tuxamon, and then he started working on it, making some changes, working on this whole state system revamp. And his fork is like from a slightly older version. So after he started working on it, I also added Sumo Bug and a bunch of other stuff. So his branch that I'm working on doesn't have that yet. So, but I can just pull it over, or I can just work from the other branch. Let's see. So let's go to resources, maps, tile, bedroom. So change these to Sumo Bug. So this is my branch now, so it's gonna have Sumo Bug and all the latest Tuxamon that I've included. Yeah, every event you create checks that. Yeah. So basically, what happens is the event system in Tuxamon, it actually loops through all of these events, and it loops through all of the conditions to see if those conditions are true. So actually, every frame it checks all of those things, but if the first condition is false, then it doesn't bother checking the rest. So, but yeah, it does all those checks. And then once all those conditions are true for one particular event, then it will execute all the actions that are tied to that. So that's the way the event system works. All right. So I just want to look, see what this Sumo Bug sprite looks like, the way it was designed. So yeah, this is my branch. So this is like the latest version of Tuxamon, the development version. Does the event know its own coordinates? Yes. Yeah, so like that tile position that it's on, it has access to that. So it can check to see where the event was placed. Yeah. So you're right, actually. Yeah, I don't think that having it all the way to the right would be that good. So yeah, if you do have like some sprites that are cut off on the left side, it probably wouldn't look nice. Because the main problem is when you have different aspect ratios. So some people might have like a wide screen. Some people might have standard, like a square screen. And so it's kind of hard to know where to put the sprites. And I don't want them, like in a widescreen, I don't want them to be far on the edges of the screen. I kind of want them more towards the center. So, I don't know, let's try, let's kill this guy. Cool, yeah, thanks, Tamashi. Yeah, actually, I didn't even realize that until you brought it up, that it may not look good if people contribute those back sprites that are assuming that it's going to be in the very corner of the screen. Okay. All right, well, I actually have to get going in a little bit, but I think we made some pretty good progress in trying to fix some of the problems that were introduced by this new state system that Bitcraft made. So there's still a couple problems, like the freezing issue for some reason has been kind of prevalent, but I think we did a pretty good job. So I'm going to commit these changes and everything. So yeah, we got our transition state. Oh, really? You're the only one who made the slice sprites? I didn't know. I haven't actually checked to see if anyone else has, but that's all right. It's no big deal. All right. So we did this. Got our combat. I'm gonna push the increased encounter rate. So instead of copying the same events, you could make a main event and make a second sub event, which triggers the main events. Okay, yeah, I see a parent-child system. Just trying to think what that would imply. So those would be like the ORs. So like you'd have one main event with like a common set of conditions, and then two like sub events. I don't know. I mean, I think that's. I don't know. I'll have to think about that. We could probably do something similar to where, there's not a lot of duplicating. You can just sort of have some references to like actions and stuff like that. So I'll have to think about that. That's a good idea though. You should try like just posting that maybe on the forums and see what other people think about it, and maybe they can add to it, make it something that looks pretty elegant. Okay. Okay. Commit. Fix. Battle transition with the new state system. Okay. All right. Committed those changes. Okay, so I think I'm gonna go ahead and stop the stream. And if any of you watching are interested in Tuxmon or contributing, you can go to tuxmon.org and there's more information. There's also some forums if you guys want to check that out.